Design and optimization of dosage regimen. To initiate drug therapy, the clinician designs a dosage regimen administered either by continuous infusion or in intervals of time and dose, depending on various patient and drug factors, including how rapidly a steady state rate of administration equals that of elimination must be achieved. The regimen can be further refined or optimized to achieve maximum benefit with minimum adverse effects. Continuous infusion regimens. Therapy may consist of a single administration of a drug, for example, a single dose of a sleep-inducing agent, such as zolpidem. More commonly, however, therapy consists of continued administration of a drug, either as an IV infusion or in oral fixed-time interval regimens, for example, 1 tablet every 4 hours, each of which results in accumulation of the drug until a steady state occurs. Steady state is the point at which the amount of drug being administered equals the amount being eliminated, such that the plasma and tissue levels remain constant in the case of IV administration and fluctuate around the mean in the case of oral fixed dosage. Plasma concentration of a drug following IV infusion. With continuous IV infusion, the rate of drug entry into the body is constant. In the majority of cases, the elimination of a drug is first order, that is, a constant fraction of the agent is cleared per unit of time. Therefore, the rate of drug exit from the body increases proportionately as the plasma concentration increases. Following the initiation of an IV infusion, the plasma concentration of drug rises until the rate of drug eliminated from the body precisely balances the input rate. Thus, a steady state is achieved in which the plasma concentration of drug remains constant. Influence of the rate of drug infusion on the steady state. It can be shown that the steady state plasma concentration is directly proportional to the infusion rate. For example, if the infusion rate is doubled, the plasma concentration ultimately achieved at the steady state is doubled. Furthermore, the steady state concentration is inversely proportional to the clearance of the drug. Thus, any factor that decreases clearance, such as liver or kidney disease, increases the steady state concentration of an infused drug, assuming VD remains constant. Factors that increase clearance of a drug, such as increased metabolism, decrease the steady state concentrations of an infused drug. Time required to reach the steady state drug concentration. The concentration of drug rises from 0 at the start of the infusion to its ultimate steady state level, CSS. The fractional rate of approach to the steady state is achieved by a first-order process. Exponential approach to steady state. The rate constant for attainment of steady state is the rate constant for total body elimination of the drug. Thus, 50% of the final steady state concentration of drug is observed after the time elapsed since the infusion T is equal to T half, where T half for half-life is the time required for the drug concentration to change by 50%. Waiting another half-life allows the drug concentration to approach 75% of CSS. The drug concentration is 90% of the final steady-state concentration in 3.3 times T half. Thus, a drug will reach steady state in about 4 half-lives. Let's have an exercise. A drug with a half-life of 12 hours is administered by continuous intravenous infusion. How long will it take for the drug to reach 90% of its final steady-state level? Answer: 40 hours. A drug approaches 90% of the final steady state in 3.3 times T-half, which equals 3.3 multiplied by 12. That approximately equals 40 hours. Effect of the rate of drug infusion. The sole determination of the rate that a drug approaches steady state is the T-half, and this rate is influenced only by the factors that affect the half-life. The rate of approach to steady state is not affected by the rate of drug infusion. Rate of drug decline when the infusion is stopped. When the infusion is stopped, the plasma concentration of a drug declines, washes out to zero, with the same time course observed in approaching the steady state. For studying pharmacological science, go to the link in the description box below this video or in the comments section. Thanks for watching and happy studies.